Hello there. Now we're so close to finishing assignment 1, it's not funny. We've got one last bit to go, and that's our final assembly. It's called General Assembly 1 at GA-01, and this is where we get all our parts and we put them together, and we also finally learn where this nut and bolt are hiding. Now I'll do my best to grab those. The toolbox that we grab them from, it's a special part of SolidWorks. I find it to be temperamental, and let's just cross our fingers it's happy and working today. So let's come across to SolidWorks 2016. We'll create a new assembly like we did for SA-01. I'll hit OK because I can see assembly is already selected. I will very snappily save that as GA-01 before we get started. GA-01, save. I'll add my description under document properties up the top here, file properties. The property name is description. The value is general assembly, and we'll hit OK for all of that. Control S, and we're going to start bringing in parts again. So I'll say insert components, and I think the first part I will add, because it is a pulley after all, will be I think it's P07. The pulley wheel is what I'm going to drop in here. So let's go to P07. We will hit open, and I'm going to hit the OK to drop that into that fixed position. So see how it's fixed, and my origins are all lining up quite nicely. It's all very centered. Yeah, it's hard to be unhappy about that. I'm excited. All right, and let's drop in next the rest of our components. So the other parts we need to bring in are our subassembly, and then our P05 reinforcing plate, and our P03 side plate, and our P06 bushing. We don't need to bring in P04, we don't need to bring in P02, and we don't need to bring in P01. They're already contained within the subassembly one. We insert the subassembly, we don't insert the discrete parts. Say open, and now I should be able to start dropping these parts down. So I'm going to drop a side plate somewhere over there. I'm going to drop my reinforcing plate somewhere over there. I'm going to drop a bushing down here, and I'm going to drop my subassembly up the top there. Now I need extras of some of these parts. I could go insert components and go through that whole process again, browse for them, add them, or if I hold Control, I can actually click and drag any part to create a copied version of that part. So I'll use that instead. I'm just going to hold Control and drag these parts out like so. Once again, we need to start putting all this together. We need to mate it. So let's go into our mates. And you know, it's good to be systematic. What I might do first of all is start putting mates between some of these surfaces. So I can see straight off the bat that text is on the wrong side. That's pretty easy to get around. All I do is instead I select the surfaces that I actually want to be touching. So I want those two to touch, and I use the mate alignment to flip the way that those orient with each other. So now we can see that that's facing the right direction. I can do the same on this side, and I can drop that in. That's all looking pretty good. The next thing I can do is, you know, start aligning maybe these center holes. Now we can actually use a power mate where we can mate a bunch of things off to one thing. So the first one I'll do is for the common reference, I will select the center of my pulley wheel. That's the common reference between all these things that fall along that bottom hole. And then I can go through and select each of the other cylindrical surfaces that I want to be part of that power mate. The bushing down the bottom is part of that. And definitely both side plates, and definitely both reinforcing plates. And so there I can see I've used one concentric mate, to apply several across a whole assembly. So it's all going to be defined by that one center of the wheel. And I'll hit OK. I'm pretty happy about that. And I'll repeat that process for the top. This time I might select the inside edge of my formed bracket as my common reference. The common reference will be blue, so just make sure that you are selecting it as the common reference. There we go. And then we can, like last time, just select all the centers that we want to fall along the alignment of that hole. Very good. Now what I forgot there is I forgot to include the bush. So if I want to go back and edit that, I can drop down the folder and I can look at my mates here. And we can see where it's added those concentric mates. So I'll go back into mate. This time I'll choose concentric. And I'll just select that bushing. Select the same common reference. Just so that there's consistency across your part. You know, it's good to keep consistency. It can make things a lot easier down the track. And now I can see it's still sort of all over the place, but I can see that all those center points are aligned. And if we actually start moving it, they all kind of move together, albeit a bit erratically. So now I'm going to use my coincident mates to start mating off those surfaces. So let's do the inside edge of our side plate to the outside edge of our pulley wheel. If you want to confirm these, you can look at this section view and see which parts are actually touching each other. I'll insert that. I'll also do the outside edge of that side plate to that outside edge of my bush. And then again, outside edge of side plate to outside edge of pulley wheel. Hit OK. And then probably all I need to do now is bring that bush at the top inside of the part overall. And finally, just make sure that the edge of my formed bracket in that subassembly is against the edge of my side plate. So that's all looking pretty dang good. Let's just save that for now. We don't want to lose that work. And we can see all the parts are nice and in line. That's moving, you know, in a non-ideal fashion. We want to take that out. As long as it's moving, it's going to be underdefined. And remember, for full marks, we have to make sure that all our parts say fully defined and all our sketches are fully defined. That being said, this text sketch, that will actually never be fully defined. So don't bust your back trying to get that working as a fully defined sketch. It's just not possible. Okay, so we're looking pretty good. We want to take out that movement. I think the best way to do that is to pick, say, this side plate and stop it rotating. So if I click the side plate, it will highlight in my feature tree. So I can see here P03 is highlighted. I can grab the front plane from that part, scroll up, hold Control, choose the front plane of my assembly, and what I'm going to do is place a parallel mate between those two parts. And that means that now if that front plane in my part is always going to be parallel to the front plane in the assembly, there's no way it can spin the way it was anymore. That's going to be limited by that mate. I'll do the exact same thing for subassembly 1. I can drop down this feature tree from here. I'll just tidy it up there. I'll open subassembly 1, grab the front plane, hold Control, grab the front plane of the assembly, and place a parallel mate between them. Hit OK. Now, I'm still underdefined, and I can figure out what's underdefined by looking at what's got the minus sign. Now, in both cases, it's the bush that's underdefined. And that's probably because it's spinning. Remember, it's only defined by a concentric mate. So that means the bush is spinning around. If I hit the drop down, I can see all the mates that are defining that bush, including its concentric mate. I can right-click that concentric mate and I can lock its rotation. And that part should then become fully defined. I'll repeat that for both of those bushes because they're both underdefined due to the fact that they are spinning on their concentric mate. So that's lock rotation. Right-click the mate and lock rotation. Now, as this goes together, we're seeing once again that this doesn't look a lot like this. That's because we need to tweak a lot of dimensions in here. Something we're not going to go over in the video. That's what we do in our class time. And I give you a lot of assistance in letting you know if you're looking like you're on the ball or not for that. Things to look for is compare the size between two parts. For example, here the bottom of my side plate is a lot smaller than my wheel. I would want to go to the side view and I'd probably see quite quickly that that's not the case. In fact, it should be the opposite. So, just look out for those details, go through with a fine-tooth comb, and keep your eye on it. Otherwise, that's looking pretty good. We're at a fully defined assembly. We've got all our parts in there. All we're missing now is our screws and bolts. So they should live in our toolbox, which is part of our design library. So I've clicked Design Library. I'll come to the toolbox, and I'll say Add in Now. Very good. I'll come to my ISO parts. I'm going to go to bolts and screws, and I'll go to hex bolts and screws. I will probably grab that grade C. That seems to be a fairly standard one. I'm just going to quickly, in my view pane, before I start dropping anything, reset my view, go to isometric, and I'm going to look at the original, and I can see which side the nut and bolts are on. So I can see that the screw insert's from the far side. So I can rotate around, so I'm looking at that far side. And then I will select my toolbox again, just by clicking that. And all I have to do is drag and drop components from the toolbox. So I'll drag and drop. I'll hover near the circle where I want to drop it. It'll give me a preview, and I can let it go. I'll give it some time to think, and I should see a dialog box appear where I can tweak the settings and the size and the geometry. So it's set to M8. We know from our drawing that it's actually an M10 bolt, so I'll change that size from M8 to M10. And as for the length, I just want to make sure it's long enough to poke out the side, fit a nut on, and still have a little bit of thread left over. So that 45mm length looks fine. In our drawing, the bolt doesn't have this washer face, that little thing I can see in there. So I'm going to go to Finish, and I'm going to say No Washer Face. Now, for thread display, simplified is fine. However, it'll look a lot prettier if we put it on schematic. So let's just do that for fun. Look at that. It looks like a real screw. That's excellent. And let's hit the green tick for OK. And there is our first screw. And we can see now I can drop as many of those as I want. I'm just going to do one more down the bottom there. And then hit the red cross to hop out of that feature. And I can see now I'm no longer dropping screws everywhere I click. Finally, come back to your toolbox. We want to come back to that ISO folder, and we want to choose nuts this time. Let's go to just plain hex nuts. Hex nut grade C. Drag and drop onto our component. And again, we wait for the dialog box to appear. M5 doesn't sound right. Let's boost that up to M10 so it's the correct size. We'll hit our green tick for OK. And then that will allow us to drop another nut up the top. we can again hit the red cross to hop out of that feature, and we'll see that now we've inserted another bolt. However, we've also inserted a problem. What a sly little mistake that was. The problem is our model is once again underdefined. And we can see that it's because these are underdefined. And like the bush, it is because they're using concentric mates and they are spinning on those mates. Both the nut and the screw and the bolt, that's all spinning. So let's lock that out. We should be able to do it quite simply by coming to our mates, where we can see the concentric mates that were automatically added by those toolbox features. And we'll right click and we will lock rotation on each of those mates. That will stop the part spinning, and it will mean that our part will be fully defined. Now, lock rotation isn't always appropriate. Sometimes you'll want it facing in a certain direction, not just randomly locked in space. When you want it facing in a standard direction, that is when you should, use something like the front plane or the right plane, top plane even, to create a parallel mate to another part to, dimension that angle or that position you wish it to sit at. So here we are, we've got a general assembly and it's fully defined. Now this model is at a point right now where, I could submit it and that part would pass, but, it wouldn't get a very good mark. There's a lot of incorrect dimensions there. There's parts that are clashing. There's a lot of groundwork left to do on that, which you're going to have to figure out yourselves if you haven't really done that in the classes. So come back to your drawings. Look really closely at all these dimensions. Check the dimensions you've got. Look very closely at this section view. Compare it to your section view. You can create a section view quickly by turning on the section view tool. You can use these arrows and angles to drag and manipulate that section view through your part. Because if you've modeled it the same way we've done in all these tutorials, yours will be nice and centered around the origin. That makes it really easy to use this feature. We can just place it on the front plane, hit OK, and we get a nice section view down the very center of our part. And now I can compare this section view to the section view in that drawing document. For example, if I look at this detail, that all fits quite nicely. If I look at my detail, it's all overlapping. There's some wrong dimension in there that needs to be fixed. Anyway, that's the end of week 3. We've had a look at how to get those assemblies together. Next week will be week 4. We'll be submitting these at the top of class. You should have all of this done before you get to class. There's not really any excuse not to be ready to submit at the very start of class. We'll be moving on quickly to the next assignment and looking at what we can do for that. Very good.